Welcome. I'm Randy Osborne. You're listening to the Bible Science for Kids podcast from a uniquely young earth biblical creationist perspective. This is Cycle 2, Lesson 17, Newton's second law of motion. But before we start today's lesson, let's do a quick review of our last lesson. Do you remember what is Newton's first law of motion? Answer: Newton's first law of motion states that an object at rest tends to remain at rest, and an object in motion tends to continue moving in a straight line at a constant speed unless acted upon by an outside force. Remember that a force is a push or a pull. Do you remember the nickname of this law? The law of what? It starts with an I. The law of inertia. Good job. Who's proud of you? I am. This is Series 2, Lesson number 17, Newton's second law of motion. Let's make sure that we remember what motion is before we consider Isaac Newton's second law of motion. In science, motion is defined as a change in the position of an object. If an object is facing a different direction or is in a different location, there has been motion. Motion has a speed like 25 miles an hour. Motion has a direction like south. And motion has a distance involved like 10 miles or 10 inches. These things can be measured by a clock, a tape measure, a speedometer or an odometer, or a ruler, and by reference to the location of another object. Do you remember what we call the ability to move things? Energy. Anytime something moves, energy is at work, pushing or pulling with a force. Listen to what God's word says to us in Judges 16:30 of the New Century Version. Then Samson pushed with all his might, and the temple fell. Question: what is Newton's second law of motion? Newton's second law of motion states that force equals mass times acceleration, or as I like to say, FMA. F equals MA, FMA. Sir Isaac Newton's formulations of the second law of motion, force equals mass times acceleration, or F, capital F equals lowercase m times lowercase a, was not based on a single observation, but rather a series of experiences and mathematical insights and reflections on earlier work by other scientists like Galileo Galilei, Johannes Kepler, and René Descartes. Here's how Newton came to his realization. First, he had faith in divine order. Newton knew that God is a consistent, honest, and wise lawgiver. Newton believed that the universe was created by a rational God who made it operate by consistent laws. His deep Christian faith helped him trust that nature could be understood through logic and math and experimentation and observation. He saw his second law of motion, the law of acceleration, as part of God's design, stable, orderly, and discoverable. Isaac Newton said, "All of my discoveries have been made in answer to prayer." Now, let's look at Galileo's previous work on motion and acceleration. Galileo had shown that objects accelerate when falling. That is, their speed keeps increasing, and that this acceleration is constant, neglecting air resistance. To show you about air resistance, pause the podcast for a moment and go get 2 identical pieces of paper, then come back and do a demonstration with me. Welcome back. Got the paper? Keep one piece flat and crumble the other piece into a ball. Now stand up tall and hold them one in each hand as high as your head is. Next, drop them both at the same time and see how they fall. See how the one that was touching more air, the flat one, took longer to fall? Air resistance is friction, slowing down things that are falling. That's how parachutes work. Galileo introduced the idea that forces are related to changes in motion. Just like the force of friction, air resistance slows down a flat piece of paper. Galileo couldn't accurately describe with math how forces change motion. Be sure to learn your math. Newton measured how force is related to changes in motion, that is, acceleration. Newton studied Kepler's laws of planetary motion. Newton was fascinated by planets changing speed and changing direction as they orbit the sun. He reasoned that such motion must be caused by a force, and he calculated that this force depends on the mass of the planet and the pull of gravity. The combination of the two forces of the moon's sideways motion plus the Earth's gravity trying to pull the moon straight down makes the moon fall down and around the Earth in its orbit. These two forces on the moon result in constantly changing motion, which we call acceleration. Acceleration is a change in motion's speed or direction, or both. Mathematical reasoning about objects that are pushed. Newton used his strong math skills to accurately describe this change in motion. He measured that an object half as heavy with the same push moves twice as far. He formalized this into a sensible equation. Capital F equals lowercase m times lowercase a. Force equals mass times acceleration. Force is a push. The mass is how much stuff is in the object. And the acceleration, remember, is that change in speed and or direction. And what do I like to say for F equals ma? FMA. It makes it fun. Why he called it a law. Newton recognized that this relationship, force causing accelerations proportional to mass, is always true in nature. The law of acceleration rules bicycles, cars, people, and planets. Because it applies everywhere, he called it a law of motion, specifically the second law. Hey, how about trying a ball and ramp experiment? What you will need? 2 balls of different masses, like a ping pong ball and a tennis ball or a golf ball. A smooth flat ramp, like a cutting board from the kitchen. A few books to elevate the ramp at one end. A light paper or plastic cup to put at the bottom of the ramp. Let the ping pong ball roll down the ramp so it hits the cup. Set the cup back up for round 2. Let the heavier ball roll down the ramp so it hits the cup. Gravity will accelerate the light ball the same speed and direction as the heavy one. Will they hit with the same force? What do you think and why? If it's okay with Mom, do the experiment after today's lesson. If it's okay with Mom. Real-life examples of Newton's second law. According to force equals mass times acceleration. Okay, why does a harder kick move a ball faster? A bigger force accelerates the same mass faster. Why can we throw a baseball farther than a shot put? Equal force on a greater mass accelerates less. Which side wins in a tug of war? The side with more force accelerates the rope more. Listen again to what God's Word says to us in Judges 16, verse 30 of the New Century Version. Then Samson pushed with all his might, and the temple fell. Thank you for listening to the Bible Science for Kids podcast from a uniquely young earth biblical creationist perspective. I hope to see you next time for Cycle 2, Lesson number 18, Newton's third law of motion. Until next time, this is Randy Osborne reminding you to keep trusting and serving the Lord. And hey, why not tell a friend about this podcast? They might enjoy it too.